Okay, so in this video, we'll be talking about integers. And so the first question that we need to ask ourselves is, what are integers? So integers are whole numbers that are smaller than 0 and are called negative numbers, and whole numbers that are larger than 0 or 0 itself and the negative whole numbers together are called the integers. So when we have whole numbers with the numbers that are larger than 0, with 0 itself and negative numbers, then we say that those are integers. So it has to be whole numbers, 0 with the negative numbers, and then all of that. The list of all those numbers would be called integers. So for example, a list of numbers from a negative infinity to positive infinity has integers within them. For instance, as you can see here, I wrote down -2, -1, 0, 1, and 2. This is a list of integers, but obviously because I'm saying to infinity and negative infinity, then we have these dots that are telling us that it goes all the way up to infinity and goes all the way down to negative infinity. Okay, so before we get into why do we need integers in mathematics, let's try out these particular problems here. So now what I want you to do is to stop the video, but to use your calculator and calculate each of these and see what they give you. Because remember, in other grades, you have found that in actual fact, you will have -5 minus 7, and you will not be able to get that answer. So when we do this, you will see such cases, right? Okay, so do that right now. Okay, so now let's move on to the next part. So now what is the importance of integers and what do we see from integers? So here's an example. On the right over here, you can see how Jimmy prefers to work when doing calculations, such as 542 plus 253. He separates them into tenses and units, and also its hundredths, and then he calculates them all together at the end, right? So after getting each of the different digit units, right? So what happens if we say 542 minus 253? You do find what 500 minus 200 is, which is 300. But now the issue is going to be when you say 40 minus 50. And when we say 40 minus 50, it does not give us a positive number. It doesn't give us a whole positive number that we are used to finding, right? Which would be 10, 15, and etc. Right? So Jimmy clearly has a problem, and his reasons as follows. So he reasons it as follows. He thinks about it and says, you know what? How about I subtract 40 from 40, which will give me 0, right? Then I'll know I'll be left with 10 that I have to subtract, right? So let's explore this approach. So let's do it ourselves. So it's 542 minus 253. And 500 minus 200 gives us 300. That's quite clear. And then we look at 40 minus 50, and 40 minus 50, you can actually separate 50 into two numbers, because you know that 40 plus 10 does give us 50. So it's 40 plus 10, that gives us 50. But why did we separate it into 40 plus 10? We needed to find a number that is going to subtract the other 40 that is ahead, right? So that's why we have 40 plus 10 instead of 30 plus 10, because 30 plus 20, I mean, because in actual fact, we want to get 0. We want to cancel out the other 40 so that we are left over with a very specific number, right? So here in this case, we are left over with 10, because 40 minus 40, this will cancel each other out and you're left with by 10. But this negative sign in front of the bracket will be taken and put at the place of positive. So now it'll be minus 10 as the answer. And same thing applies here. We have 2 minus 3, and 2 minus 3 we can write as 2 minus, in the bracket, 2 plus 3, because 2 plus 3 is 3. 2 plus 1 is 3. And 2 minus 2 will cancel each other out, but you'll be left with the subtraction sign. So you can just think of it as moving the subtraction sign to the leftover number, and then we'll give you minus 1. So then we apply how he did it as well in this case. And what he did was he's just added them together. So it's 300 plus negative 10 plus minus 1. And that will actually give you 289, right? And basically, if you notice something again here, a very subtle point is that you're still going to have to use your BODMAS, right? The idea of BODMAS and how to use it correctly, okay? Okay, so now you probably agree that 5 plus negative 5 gives us 0. You can try that on your calculator. Put it in your calculator and you find that it is 5 plus negative 5 gives us 0, 10 plus negative 10 gives us 0, and 20 plus negative 20 gives us 0. But there's something quite interesting about this, and it's something that we were using this particular concept here, but we did not state what it is. And this concept is what we call the additive inverses of numbers, of the positive whole numbers, right? So two positive and negative numbers that correspond, for example, is 3 and negative 3. And why do we say it corresponds? But imagine here, if we have 1 and 2 there, and then we have minus 1, and then we have minus 2. If you notice, the spacing from negative 2 to 0 is 2, right? I moved 1, 2, but also from 2 to 0 is 1, 2. So there is some kind of correspondence, because if I had to fold this number line, right? If I had to fold it at 0, you would find that this 2 will fall straight on top of the negative 2. So there is correspondence, but we can also think of it as an opposite of that number. So in actual fact, what is the opposite of negative 2? It's 2. What's the opposite of negative 1? Is 1. What is the opposite of negative 10? It is 10. What is the opposite of 39? It is negative 39. So that is an additive inverse. And an additive inverse is that number that when we add it together, you can find that it gives us 0, right? It gives us 0. When we add them together, it gives us 0. And you'll know that you'll have additive inverses. Now, what is the importance of additive inverses? Yes, we did use additive inverses in the example before about Jimmy, but now let's look at it in more depth, right? So for instance, if you have 8 plus negative 5 is equals to 3, we know that it's equals to 3, right? But now, what can additive inverses do in this case? So let's look at this. You have 8 plus negative 5, which is equals to 3 plus 5. But now remember, 3 plus 5 is just, we separated 8 into 3 plus 5, because 3 plus 5 is 8. And then we have 5. So now we have 5 plus minus 5. And 5 plus minus 5 is exactly the same as this notation of the additive inverses. Therefore, you know that this entire calculation here, which is 5 plus negative 5, would give you 0. Therefore, it would be 0 plus, it will be 3 plus 0, which will give you 3. So you see how additive inverses have made this calculation more easier, right? So here is some exercises that you can try to just get the feel of what an additive inverse is. So I'd like for you to try all of them, and then if you have problems, obviously you can ask the person who's helping you, and if not, you can also ask ourselves. Okay, so let's move on to something even more interesting. So now, when we talk about integers, there's a certain thing that we need to understand about integers, right? That we can actually look at integers in terms of bigger and smaller than and or equals to, right? And in that case, what is actually happening there? So think about this. When we look at 3 comparing it to 2, we know that 3 is bigger than 2, but 2 is smaller than 3, right? 2 is smaller than 3, but 3 is bigger than 2, as 2 is bigger than 1 and 1 is smaller than 2, right? So if you notice, whenever I say it's smaller, when I say a number is smaller, I say 1 is smaller than 2, and then I say 0 is smaller than 1. I say it's minus 1, that is smaller than 0, and it's minus 2 smaller than 1. It's minus 3 smaller than 2. what's happening? I'm moving towards the left. And each time I move to the left, to this side, it gets smaller. So each time I move this way, it gets smaller and smaller, right? But if I say -2 is bigger than -3, -1 is bigger than -2, a 0 is bigger than -1, 1 is bigger than 0, 2 is bigger than 1, 3 is bigger than 2, 4 is bigger than 3, 5 is bigger than 4, and so on and so forth. You can see that whenever we're moving on the number line, it is getting bigger when we move to the right-hand side, right? So basically, if you had an example where it says -103 and -99, if you had to have imagined this 199, you would see that in actual fact it would be on the right-hand side, and -103 would be more on the left-hand side. So since it's more on the left-hand side, you can automatically see that this would be that -103 is smaller than -99. And remember, the pointy side points to the smaller number, right? Okay. And so you can see that you can try the rest out, and I'd like for you to try them out. And again, if you have any problems, please don't hesitate to ask the person helping you, or you can send it through. You can send the question through to ourselves, and we can try and help you there. Okay. And then we have another example, and this is a problem example where it says, on a winter's day in Uppington, the temperature rose by 19 degrees. If the minimum temperature was -4 degrees, what was the maximum temperature? So in actual fact, how would we calculate this, right? So we would calculate this by saying that, one, -4 degrees plus 19 degrees, when we add it together, it will give us 15 degrees. How is that possible? It's because when we add, it still uses the same method, and you'll find the answer. Okay. And now we'll look at multiplication and division. So when we look at multiplication division, clearly what actually happens there, it's actually the same thing, right? So when we say a negative times a negative, it will give you a positive. A negative times a positive will give you a negative, and a positive times a positive will give you a positive. And same thing applies for division. A negative divided by a positive will give you a negative, and a negative divided by a negative will give you a negative. Give you a positive, sorry, and a positive divided by a positive will give you a positive. Okay, so this is the calculation that we are using. Now, I'd like for you to try out the examples as the final exercise, but I did give you a hint at the bottom where we say 3 in brackets 2. It actually is the same as saying it's 3 times 2, just as a reminder, right? So that you don't get confused when you do D and B, right? So when you do D and B, hopefully you'll be able to understand what's happening there. Other than that, I really thank you for watching these videos. I'm extremely grateful for you taking the time to do these videos. And I hope that you do these exercises, because they will help you, and they will help you to get to the goals that you have set for yourself. Other than that, I thank you for watching this video, and I'll see you next time. We pray, oh my Lord, will my peace